All right, typically you do significance in terms of slope, though. We did it in terms of the correlation coefficient in stats 1. We're going to move towards the slope in stats 2. So beta, because when you do the population model, beta is the uppercase beta is the slope of the population model, and b is the sample slope, which we found from the actual data, basically. So you assume that the uppercase beta is 0, which means there is no linear relationship. And of course, if b is not equal to 0, there is a significant evidence to say that it is a linear relationship. You can do the more specifically beta less than 0, greater than 0 if you want to be a more specific or more exact test to specifically prove positive or negative, but we're not going to do that. So again, if you look this up online, you can actually do it as a t-test or an f-test. We're going to specifically just do a t-test because you don't need to do both to give it the exact same answer either way. And again, you still have to have randomization. It must satisfy linear regression model, obviously, like before. It must be normally distributed, all that kind of stuff, right? All right, so the t-statistic here is this. So we're going to do this again with this t-statistic, okay, for the same values. So actually I'm going to copy this, and we'll go to our spreadsheet for the cars, and then we will do this again. Let's move this one over to here, and we'll move this one over to here. And we'll do t-stat. How's that sound? I like that. That works. Okay. It'll be the same t-critical because what we're going to do here is the same 3 basically, right? All right, so we need the SE, which is the standard error of the slope, which is this formula here. So all we really need is the latter part of it, though. I wonder if I put it in here, if I can. I can, good. I'm going to delete all of that. Ooh, that is not good. Let's just delete that. Okay, let's just copy this to here. And we're going to delete all of that. And I'm going to use that and put that in the spreadsheet now. Oh, that works out good. Okay, let's start with the, so we need to get the SE first to be able to do this basically, right? That's the problem. Okay, so we need the SE. Okay, so the things we're going to need first are the individual value, which we have, and then the y hat, which we probably don't have. Yes, let's get the y hat. So insert. Here we go. So we need y hat. Okay, so that is going to be a plus b times the x. Right, and these don't change. $sign, 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 $sign. All right, so there's my y hat. And the next thing we need is the residual squared, right? So y minus y hat squared. Oh, gonna insert here. Insert y minus y hat squared. So we need the observed minus the predicted squared. Let's see here. A plus B times x. I think I got it. Yeah. No, I didn't get that right. I clicked on the wrong one, that's why. Yep, because you have, shoot. Let's try that again. Observed y minus the predicted y. Wow, well, I couldn't get that right. Whew. We're going to sum those up. Okay, so that number right there is my numerator here, correct? Now we need the individual values minus the x mean, which I have here, right? So we're going to insert, so it's the x minus the mean of x, right? I believe I need the square of those also. Yep. Okay, so I need the x minus the mean of the x, and we need to square it. And this doesn't change. We're going to put a dollar sign because it's always going to be this value here, right? We'll drag that down. Equals the sum of all those. All right, so we should be got a standard error now, right? Okay, so if we do our standard error, it's equal to the square root. Okay, so our numerator is this one right here, divided by the degrees of freedom, which is n minus 2, and then divide again, right, by this, which is this one right here. Okay, that should give us our standard error. Okay, so our t is basically our b value divided by the standard error. Okay, and look at that. Did it give us a different answer? No, it did not. Okay, so the outcomes will be all the same, basically. So I'm not going to bother going through and doing any of these, because it's all the same. Let's try one more time. So I'm going to copy these, right? Absences. We'll go up to here, right? And we'll do, the formulas are over here. Right there, and right there. So this one should give us the same answer again. All right, so we need the y hat, right? So a plus b times the x, right? And these don't change. Okay, drag that down. Insert. So we have the observed minus the predicted squared. So observed minus predicted squared. Drag that down. So we need the sum of that though. So we do need that number. That's important. And then we need the observe minus the mean squared, right? So I might have screwed that up, but that's okay. The observed minus the mean squared, but the mean doesn't ever change. We're going to keep a dollar sign on that. Get that backwards. The mean of the x. Okay. Drag that down. Okay. Drag that across. So now we have the sum of all those ones. Those are our two pieces there, right? Okay, so we can do our standard error, right, which is equal to the square root. So the numerator is this one divided by n minus 2, and then divided again by this one. And we should get the same value now when we do the b divided by the standard error. So I don't need to repeat the rest of the problem now. It's the same outcome. Okay, last one. This one should fail now, right? So let's copy these, copy, and go to here. All right, put that up there, put that there. Okay, so we have insert, and we have y hat. So a plus b times x, and these don't change. Drag that down, insert, insert. So this one is y minus y hat, observed minus predicted squared. All right, and this one is observed minus the mean squared. Oop, I didn't drag that one down. I don't know why I didn't do that. Hold on, I'll drag that down one more. Okay, so we have the observed minus the predicted squared. Whoops. There we go. And then we have the observed minus the mean squared. But the mean doesn't change, so we're going to put a dollar sign on that. Drag those down. We need the sum of all those, right? Oops. Drag that across. So those are the two important values there. Alright, so my standard error is the square root of residuals by residual squares divided by the degrees of freedom, which is n minus 2, divided by this one, close paren. I get that there, so I should get the same value here. So my b divided by that should give me this, so I don't need to do all the rest because everything else is the same as far as the hypothesis test is concerned. Okay, so all the answers here remain exactly the same. The only thing that differs is the original hypotheses. So now the original hypotheses is beta is 0 or beta is not 0, basically. So we're proving if the slope is 0 or if the slope is not 0. So it's not using the correlation coefficient anymore, right? So I'm going to have you do them this way also, because we want to also do the confidence interval for where we think the true slope will fall, which we'll do.